Let's now try to summarize whatever we have learnt on TLB. If a page reference, the page whichever you are referring, if that particular entry is in TLB, the time taken is very less. If it is not in TLB, then maybe we might have to waste some time, right? So I'll just analyze it. Let us say TLB access time is t units, some t units, t seconds or t milliseconds, microseconds, and main memory access time is m units. Let's just assume that t units is the TLB access time and main memory access time is m units. Okay, and then let us say TLB miss, not the hit. Just be careful, TLB miss rate, which means the possibility that the referred page table entry is not in TLB is P. I'm not talking about the hit rate, I'm talking about the miss rate. Just be careful about that. Okay, if this is the scenario, then what is the effective memory access time? Effective memory access time. So what is effective memory access time is nothing but we want to get one word from the memory. Then how does it happen? How do we go to the memory and get it? First thing is, before you go to the memory and get the word, you have to get the page table entry and convert the virtual address to physical address. Then you go to the memory and get it. So in case if it is TLB miss, which means P is the TLB miss, right? In case if it is TLB miss, then we have, how do you know that it is TLB miss? After t seconds only, t units only, we can know that it is TLB miss. Yes. So once we find out that it is TLB miss, then we are supposed to go to the memory, and from that memory we are supposed to get the page table entry, which is going to take m, and then access the required word, right? In case if it is a hit. So what do I mean by hit? In case if it is present in TLB, which means 1 minus p, just be careful with p and 1 minus p. Here p represents miss. Till now in all the questions which we solved, I have shown you p as the hit, but just for the sake of simplicity I am doing this. You can do anyway, right? And if it is miss, if it is hit, then it is already present in the whatever entry you are looking for is present in TLB, and then you can directly go to the main memory and you can get it. Okay. Now if you just summarize this, what I get is, I get p into t plus 2m, isn't it, plus 1 minus p into t plus m. Then what do I get? You need not by heart it. Please don't by heart any formulas, nothing. It is all logical, right? Don't by heart anything. My intention in teaching you all this is not that you by heart all this and go to exam with a lot of tension. The more you by heart, your mind will be more nervous, because you have to remember a lot, right? So now PT and PT will get cancelled, and then here there is 1 p.m. and here it is 2 p.m. Therefore I can write it as I can write it as t plus m plus p into 2m. This is what I can write it as. Okay. So what does it mean? Effective memory access time is, in order to access a word, so first you access the TLB. There is no way you can skip it. So either you like it or not, you have to access the TLB. In case if it is present in TLB, right, then it is a hit. Then you can directly go to memory and access it. Otherwise, first you access the TLB, then if it is a miss, right, then you go to the memory. That is why the probability is less. The probability of miss is this, right? So access the TLB. In case if it is missed, there is still some probability. Then you might have to go to main memory and get the word, right? Are you understanding this? What I mean to say is, in case if it is hit, you can directly go to main memory and get it. In case if it is miss, right, then you might have to go to main memory and then get the word. So how can I summarize it is, I think this is only 1m, right? Yeah, check this. It is 2 p.m. minus pm, it is just pm, t plus m. See, In case if it is present in TLB or not, you have to definitely access TLB. Therefore, T is always going to be there, right? In case if it is not present in TLB, then also T has to be there. Then with some probability, you might have to get into the memory in order to access the page table entry. So once you get the page table entry, finally you have to definitely access the word. Therefore, effective memory access time minimum is this. Whatever is the miss rate or hit rate, whatever that is secondary, always the minimum is this. So above this we have to do sometimes more work and sometimes less work with some probability, right? So this depends on what is the miss rate. Are you getting this? So now if you consider this entire thing as this it is, see, if you can follow it, otherwise skip this video completely, not an issue. So now let us say effective memory access time is represented with y, and then this t plus m is represented as c, constant c, plus page hit rate is represented as x, and then this is some a. Then y equal to ax plus b, that is the line we have here, right? So if you plot the graph, what happens is you can watch that the graph will have, which means effective memory access time, and here page TLB miss. As the TLB miss increases, effective memory access time will increase this way, right? As the TLB miss increases, this one, as the TLB miss increases, the effective memory access time increases. So there is a directional proportionality. Therefore, in order to keep the effective memory access time less, you have to keep the TLB miss less. How can I keep the TLB miss less? So whenever you try to replace any TLB entry with some other entry, see that the replacement algorithms work well. That is where replacement algorithms are going to be very useful, right? That is going to decide everything. Now what does it mean? What is this one? This one is t plus m, right? What does it mean? Whatever happens, effective memory access time is never going to come down below t plus m. The reason is, if you have to access one word, you should definitely access the TLB and then the memory. So whatever happens, your effective memory access time will never come below this. That is for sure. And after that, there might be some extra time which depends on the TLB miss rate. Getting this? So you can think of it this way. So effective memory access time equal to t plus m, which should always be there, plus miss rate into m, right? And now in the light of this explanation, using this formula, what you could do is take all the previous problems and just substitute in the previous problems this formula, and you'll get the same answer. You please do it yourself. Whatever questions we discussed on TLB, either gate questions or some practice questions, you please substitute this in this formula all the values, and you get the answer. They all should agree, okay? And next thing is, it is not just that it is whatever explanation I given you here, I assumed that our page level is one level, our page table is one level page table. In that case, whenever there is a TLB miss, what we did is we have directly gone to the main memory, and with one access time I got the entry. But in case if it is multi-level paging, right, let us say there are k levels, then what happens is, in order to get the page, one page table entry, we might have to access the main memory k times. Then what will be the change? See, if you understood it, it is fine, you can leave it. I'm just trying to extend it. They have never asked such a model, and I don't think that they'll really ask it, but let's be in the safer side. So what is that I'm trying to do is, I'm combining TLB with multi-level paging, which is actually practical. In most of the operating systems, it is being happening, but no practical questions are there, and no gate question has ever been asked. But then still, let's do this. Now what I mean to say is, if I have many levels of paging, right, then if there is a miss in TLB, in order to get that entry which is missing in the TLB, I might have to refer various levels. Therefore, more than one access time is required in order to get that entry. How many access times are required? That depends on the number of levels in the page table. So in this case, assume that number of levels, page table levels we used are k, right? Then what happens, whenever there is a miss, I'll find out that there is a miss from the TLB, and when I find out that there is a miss, then I'm supposed to search for that missing entry in all the k levels, right? So let me say it is k. So k into m, the reason why k is written here is whenever there is a miss, I might have to search the main memory k times because there are k levels of page tables, and then only I can get the entry. Once I get the entry, everything is normal, like you can just get the word in one memory access time, right? And this is nothing. So if there is a hit, then you need not go to the page tables and all the levels at all, right? This is going to be same. Then what happens here, instead of 2 I get 1 plus k, isn't it? And then what happens here, instead of 2 into pm, I get 1 plus k into pm, right? Then what happens here, instead of all this I get km. So now everything will make sense. Watch it. Now effective memory access time is, if it is present in the TLB or not, you should definitely go through TLB. Therefore T plus you should get the word from memory. And sometimes if the required TLB entry is not there in the TLB, page table entry is not there in the TLB, you might have to go through various levels. I mean, you might have to go and search in all the levels of the page table. If there are k levels, then you might have to access the main memory k times. That is why this is the formula, right? And everything will be same. So instead of the graph will be same. So as the page TLB miss increases, effective memory will increase. And you can even change x with either p or k or m. As the number of levels increase, then the effective memory access time will increase. As the main memory access time increase, that is if you want to draw a graph with main memory access time, then you have to pull this one also as common. Anyway, you will get the direct proportionality, right? Fine. So anyway, my intention is to show that the effective memory access time is depending on the TLB hit rate. Got it? Fine.